Okay, today we're going to learn how to analyze parallel circuits. So the first thing I want to do is go back and recap some items from the lab that you should have learned when doing the parallel circuit lab. So I have the chart right here for when we did the 10 ohm and the 5 ohm resistors in parallel. So you should have found that the voltages were pretty close to the same, whether you measured the voltage from the power supply, resistor 1, or resistor 2. Now we do lose a little bit of energy in the wires, so it's possible that this voltage right here could be slightly higher, but in general they should be pretty close to identical. Alright, if you made your current measurements properly, you should calculate your resistance by V divided by I equals R, and you should become really close, or these should be very close to the nominal values. Now there's a tolerance with these resistors, so they're not going to come out perfect. Alright, so as you can see, we already have some significant differences from a series circuit. In a series circuit, we saw that the voltages add up. Now, in a parallel circuit, the voltages are the same. However, in a series circuit, the currents were the same, and now this parallel circuit, the voltages add up. The currents add up. Now we have this really funky thing going on where we have one resistance, another resistance, and they don't add up at all. They actually got lower. Alright, so why did the resistance actually get lower? The resistance got lower when we put more resistors in parallel because we provided additional paths for the current to flow. So we get more current because there's less resistance. And there's less resistance because there's more places for the current to go. So if we look at this, on both of these, we have a change in voltage from this side, I'll say from A to B, all right? We have a change in voltage through here of almost 4.75 volts, or just, all right, on every one of these. In this resistor, we get 0.46 amps. And in this resistor, oops, I have a 5 here. This should be 5, not 20. Alright, and in this resistor right here, down here in the 5, this is 0.95 amps. Alright, so what's that mean? That means current coming out of our power supply was actually 1.44 amps, or the sum of these two. You can see that these don't quite add up, but again, that's just round off error. So let's try to figure out how we actually find this resistance. So for some reason, I had you calculate 1 over R. So let's look at these values. So 1 divided by R for this guy is going to be 0.97. 1 over R for this one, 0.202. And 1 over R for this column is going to be 0.303. Okay, you should note that this pretty closely adds up. All right, this actually is 0.299 when we add them up. Very close to 303. Again, within some rounding error. So that brings us to how do we actually add up resistors in parallel? So in parallel circuits, we use what's called the reciprocal rule. So let's add up these two resistors using the reciprocal rule. So 1 over R total, which is this guy right here, All right, so 1 over R total is going to equal 1 over R1 plus 1 over R2. So let's solve that. What do we end up with? 1 over R is equal to 1 over 10 plus 1 over 5. Now our lowest common denominator is going to be 10. So this is equal to 1 over 10 plus 2 over 10, which is equal to 3 over 10. Now that value was actually 1 over R. Okay, so if we look at this, if 1 over R is 3 over 10, then R is 10 over 3, which is 3.33. So 3.33, that's our actual value using these nominal values. Our experimental value that we calculated was 3.03. Pretty close. Why is that? That's because these resistors aren't perfect. Nothing's made perfect. So they have about a 10% tolerance. So this one could be anywhere from like 9 to 11. So 10.3 for that guy is actually pretty good. Same thing with this one. This would be anywhere from 4.5 to 5.5. All right, so that's how we add resistors in parallel. Let's look at the top of page 15 in your packet. All right, so if we look at this, our rules for parallel circuits are going to be to find the total resistance, we add the resistors using the reciprocal rule. All right, in a parallel circuit, the currents add up. Just say add. In a parallel in a parallel circuit, the voltages stay the same. So let's use this in an example problem. So the first example problem, we have 6 volts. All right, the 6 volts is coming from the battery. So we know we're going to have current going that way. All right, so the 6 volts coming from the battery is going to be down here, the total, 6. We're going to have a resistor, R1, of 20 ohms, R2 of 5 ohms. All right, so that's everything that we have given to us so far. Now, let's take a look at some of the things that we can actually fill in. So we know voltages stay the same. So we can make this voltage 6, and we can make this voltage 6. All right, so these are the same.
It's not turning on. Guessing bad. Oh.